Okay, here we go. I'm going to do just one more thing, okay? I'm going to do just one more thing, okay? So, what I'm going to do is I'm going to place in here, I said I'm going to multiply through by 5. I'm actually going to factor out a 1/5, okay? If I factor out a 1/5, I have negative 1/5. Sorry. Negative 1/5. Think about this. If I factor out a 1/5 from 20, what are you left with? You factor a 1/5 out of 20. You get 100. Right? And here you would have minus b. Okay, so we have negative 1 over 25 times 100 minus b. If you multiply through by 5, we can't really do that because we're not multiplying the other side by 5. Okay? So please look at what you have. This is the expression, and we're going to use it. Okay? It says find the second derivative and explain why this graph cannot resemble the original. Explain why it cannot represent the original. So, as you look at this graph, if we plug in the values 0, 10, 20, 30, 40, 50, so on and so forth, what do you notice is true about this part of the expression when you plug in any of these values? Okay, it decreases, but it's always positive, right? It's always positive. And then you're multiplying it by a negative. So the resulting value will always be negative. What does it mean when the second derivative is negative? The second derivative yep, is negative. Therefore, the graph is always, I'm sorry if somebody said it and I didn't hear it, if you have a second derivative that's negative, what does that mean about the sketch of the graph? It's always concave down. Is the graph concave down the entire time? The given graph is concave up. Now, is it only concave up? It's concave up at the beginning. So at the beginning, when we're plugging in values like 0, 10, 20, 30, 40, the weight of the bird, okay? So there's no way that that could be the original graph. We all good? Okay. Part C says use separation of variables to find the particular solution. Separation of variables to find the particular solution. So, should be right up your alley. What do you want me to do? Okay, yep, I've heard a couple things. dB is equal to 1/5 times 100 minus b dt. And you have to get the variable b over on the other side, so we're going to divide or multiply by 1 over 100 minus b. So, like I said, the next test, the lowest grade you can get is a C. I can always change that so it can go down an F. We could go 5, 4, 3, 2, 1 versus an A, a B, a C, a D, and an F. I mean, I can always do that. I've been trying to express graciousness considering the situation that we are in. So, okay, let us do the antiderivative of 1/5 dt. Antiderivative 1/5 dt. T plus a constant, okay? So I need to do this antiderivative here, okay? And I have, say, what is the antiderivative of 1/b? What if I just had 1/b? I would get the natural log of b. So what we're going to have instead is we're going to have to use some substitution here. The substitution will be as follows. U is equal to 100 minus b. So du is equal to negative db, right? So I'm going to multiply by a negative. Negative du is equal to db. Now I can make my substitution. My substitution is negative integral of 1/u du. What's the antiderivative of 1/u? Natural log of b. So I have negative natural log of 100 minus b. What now? I'm trying to find the particular solution. Plug in what? 0 for time and 20 for b. So I get negative natural log of 80 is equal to c. We are almost home free. Negative natural log of 100 minus b is equal to 1/5t minus the natural log of 80. Solve. Nope, because it's already positive. Natural log of 100 minus b is equal to natural log of 80 minus 1/5 t. Now what? Create a base of e. Yep, so we're going to rewrite this. You know, you have a couple ways that you can rewrite it. I'm going to write it as e to the natural log of 80 and then times e to the negative 1/5t. Now, some people put it as divided by e to the 1/5t. Either way is fine. Either way is fine. So what is e to the natural log of 80? 80. So you can see that you end up with a coefficient of 80 in front of this. And then we subtract the 100 and divide by the negative. So negative b is equal to 80 e to the negative 1/5t minus 100. And divide by the negative. B is equal to 100 minus 80e to the negative 1/5t. And if you did decide to write it as b is 100 minus 80 over e to the 1/5t, I'm sure that they would, you know, obviously give you credit for that as well. So, yeah, you could write, you know, plus 100 off the end instead as well. It's totally up to you. But what you have to make sure you do is you explicitly solve for b. So leaving a negative out in front, that would definitely not be accurate. So as we check our answers, let's see what we got. Whoop. Oh. Here we go. I have 12 and I have 6, which I came up with. And so I get 1 point for using that derivative, which we spoke to. And then because 40 is greater than 70 in that situation, the 40 comes out. This one, you can see that the complicated second derivative, they do come up with that negative 1 over 25. There's a couple ways you could express that. But, notice the concave down for 20, between 20 and 100. And that's what we talked about for those initial values. In this situation, we isolated the variables. Notice separation of variables. There's 5 points in this piece here. So if you just separate the variables, that's a point for you on the AP exam. Solving for the constant, coming up with negative natural log of 80, we get a point for that. Coming up with the constant of integration, the plus c, they just give you a point for that, it looks like. Using the initial condition, plugging in the 20 and the 0. And then solving for b explicitly, so you don't have the 100 minus b. Yes? I think when it says 1 for the constant of integration, I think what they mean is this. If you take the antiderivative and you forget the constant, then it's a point off. I don't think that if you take the antiderivative and you come up with the wrong thing, but you have a constant, I don't think you get any points for it. No. So it assumes, so it's kind of like you got to have that and make sure that you get the constant. So it's preceded by the antiderivative being correct. So the antiderivative, so notice it says max of 2 if no constant of integration. So the most you could get is if you forget the constant, which means you wouldn't solve for the rest of the problem, then most you could get would be 2. 0 out of 5, if you don't separate the variables, then you got no shot at all. So anyway. At the end, it does say t greater than or equal to 0. I don't know if they ask you to specify. I doubt that they would say that you have to define that time will be positive in that scenario. Question? Yeah, so when I did the problem and I took the derivative, and so this was just, again, I knew something was going on, and what my indication right away was when I took this derivative, I did, so dB divided by dt is equal to, I distributed the 1/5, and I got 20 minus 1/5 b. And so in my head, I was saying to myself, which, yeah, I said, well, it's with respect to time, but yet I have a b variable there. And so I was like, well, this should be negative 1/5 b prime. And then you would take this b prime, plug it back in. That was in my brain, but I was like, well, no, I'm sure that I must have something. I'm sure I'm making it too confusing. And so I was like, well, so I guess that the derivative is just negative 1 over 5. So therefore, the second derivative is always negative and it's concave down, and where this graph is concave up. So I got the rest of it, but I came up with second derivative just equal to negative 1 over 5. But I had that voice in my head saying, wait a minute, something ain't right here because you have a b value there, and it's with respect to time. If this was a t value, then it would be negative 1/5. But because it's b, it's negative 1/5 b prime. And then you got to plug that b prime back in. So that was my mistake. So I would have gotten 8 out of 9 in that situation. So your assignment is as follows. You want to do these problems. Again, these are added to your work. Separate sheet of paper. I want problems 6 and 7. So from the first review, you do problems 4 and 6. From the second one, you do 7 and 8. From section 3, 5 and 6. And from 4, you do 6 and 7. Okay, so those are the 8 problems you have so far. And I will add 2 more next week for a total of 10. That should be completed on a separate sheet of paper. Again, if you need to check your scoring, you could go to the AP site, or I'm sorry, simply to my webpage. I have all the information there. It's okay to not get all the points.